Hi everyone, good evening. I am Pavarnab and today we will start the Newton's laws of motion. I hope you have completed the previous chapter that you have in your syllabus, and maybe you all have your exams soon. So today let's start the chapter of Newton's laws of motion. Okay, before starting the chapter, let us talk. Let us talk about something that we observe in our daily life. Okay, because physics is all about the rules and regulations of the universe and uh, how we are applying it in our daily life. Okay, this just helps us to make the works easier that we are being constantly doing. So before starting, I want you to know about momentum and inertia. I hope all of you know about the terms inertia and momentum. We know that every object, every physical object, more correctly, has some mass. Okay, so every mass possesses some properties. One is the inertia. It is not a force, it is a tendency. Okay, it is a tendency of what? It is a tendency of being in the state of I mean, that it wants to resist the change of state of the body. That means any body having mass have the tendency to resist the change of the state of the body. That means whenever some force, we are applying some force on something, then the force tends to move the object or it tends to change the shape or anything. So inertia is what? It is the tendency of the body that it will try to be in rest if it was in rest, and it will try to be in motion if it was in motion. So this is a kind of resistance offered by the mass. So this is all about inertia. And then comes momentum. Okay, I am not going into the silly examples of our daily life. It is just, if you want to correlate, then you can just assume that you are moving in a, or you are traveling in a bus. The bus just applied some sudden brakes, then what will happen? You will tend to move forward. So what is this? This is nothing but you are in motion, so your body was trying to be in motion. Even after applying brakes, it was tending to move forward. So this is all about inertia. There are lots of example present, you can find out by yourself in our daily life. So I am not wasting much time in it. Moving to momentum, what is it? It is the if we want to define it in our layman language, it is the mass in motion. Momentum is nothing but mass in motion. I hope that this color is not visible from there. Let me check. Yeah, I'm right. Okay, no issues. This is nothing but mass in motion. We all have gone through the formula that momentum is denoted by P and is equals to m cross m into v. V is here velocity. So momentum is also velocity because it has some direction. Now, what does it mean? What does momentum mean? If a body is moving along some direction, having some mass m, let's say m is the mass of the body, then how, with some velocity of course, let's say v, then how much motion it is possessing into itself is the momentum of the body. It is nothing but the quantity of motion possessed by the body. Because of what? Because of the product of its mass and velocity, nothing else. So momentum is expressed in this form. This is the mathematical expression. P is equal to m into v. From the expression itself, you can notice that P is a vector quantity. So that means that it will have some magnitude and some direction. No question in that. Now, if we want to correlate momentum with our daily life, then what you can say is that, let's say a body is moving towards you. You are here. A body is moving towards you. Now you can feel the momentum thing in a way that when the body is moving towards you and you have applied a certain amount of force, okay, you have applied a certain amount of force to uh, change the state of the body from motion to rest. The amount of force that you have applied here, you can quantify momentum in this case. So moving forward, this is all about momentum and inertia. These are the terms that are new to us, or we have already learned them somewhere, but still this is the basic thing we need to know. Now moving to the laws of motion. Okay, so if I ask who is Newton, what will be your answer? What are you going to say? That Apple guy, or something else, or that guy who just turned his pain into invention? Because after all, Apple, that fall on his head has definitely given him some pain. But without pain, there is no gain. So what is his gain? It is the invention of, or discovery of, discovery. I mean gravity. In simple words, gravity. So now we have to give ourselves enough pain, so that we can understand the Newton's laws of motion. Because it will not be cup of tea for everyone. So let's start. We all know about the laws of motion. What are those? There are three laws. Who has given them? Newton. I'm going to finish the laws in this only. In this, I can tell it a slide. Okay. We all have understood what I have tried to say. Now, what is the first law? It is all about inertia. Though inertia has not been discovered by Newton, but one law is based on inertia. That is, a body at rest or in motion will try, or you can say tend to be at rest or in motion unless until some external unbalanced force. More, if you want to be more specific, we will say that unbalanced force is being acted on the body. One thing we have missed is that a body having some mass, because inertia is the property of mass. No massless body can have the tendency, have the property called inertia. I hope it is clear. Then comes the second law. It is all about momentum. How? We have read that second law is all about F equal to ma. But no, in actual case, the second law states that any external force acted upon a body having some mass and which is in motion will be equal to the d dt of it. d dt of it means d dt of momentum. So this is the mathematical expression of second law of Newton or second law of motion given by Newton. So how the F equals ma comes? F is also a vector quantity. How the F equals ma comes? Let's understand that. What is it? Differentiation. If you want to find dp, what we have? Sorry, not dp. If you want to find F external, equal to d of mv by dt. Apply the chain rule here. What you will get? Nothing but m constant dv by dt plus v constant dm by dt. This is the actual expression. But now if you observe, you will find that dm by dt, what is it? It is, I mean, mass is not variable. In, uh, in most of the cases, or I mean almost 90% of the cases, mass is not variable, it is constant. So differentiation of any constant term becomes 0. But there are some cases where the mass becomes variable. Now you will say where? How can mass be variable? Okay, let me explain. Let's say rocket. It carries a huge amount of fuel in it because of its requirement of a higher thrust. Now, the dm by dt of the fuel keeps on changing constant, I mean at a constant rate or at a variable rate, I don't know. But it keeps on changing, that I know very well. So it is variable. So in that case, what do you think? That we will have something here, not zero. And this is the case. This is the case. In the case of rocket propulsion or any other cases where the mass is variable and it is being stated in the question, then you have to use this particular expression. You can't use F is equal to ma directly. So this is the actual law proposed by Newton, and we call it as the second law of motion. Then comes the third, the most popular and the most favorite of us. Every action has some equal and opposite reaction. And what we miss is that acting on different bodies. That are involved. Okay, so they are acting on different bodies and they have the same line of action of force. So this is all about the three laws proposed by Newton. So this is all about the laws of motion, and I am ending the lecture here because I want you to give some time to digest